and welcome to another episode of 3-minute videos with Nathaniel. Today we will now solve question 1b of MAT Oxford 2014. The question asks to find the graph of this. For logs, let us review the basic properties of logs. Firstly, log A equals to 1. Log A1 equals to 0. These are the only two properties of logarithms we are only going to use. Now let's look at this quadratic equation. Obviously, we don't have to find the solutions, but we can use a method to find out how many solutions it has using the discriminant. B squared minus 4ac for any quadratic ax squared plus bx plus c. B squared minus 4ac will now evaluate to 2 squared minus 4 times 1 times 2 equals to minus 4. Oh dear, it's negative. This means that we do not have any real solutions. In other words, this quadratic never touches 0. It's a pity, right? It can only reach up to 1 and onwards. But one more additional property of logarithms is required to distill the graphs. Log A0 equals to minus infinity. That's an interesting property, isn't it? Well, it is. It just is. This shows that we need to find the minimum of x squared plus 2x plus 2. To do this, we need to find its derivative. The derivative of x squared plus 2x plus 2, so dy over dx equals to 2x plus 2. So we should equate it to 0 for any minima. X equals to minus 1. So now we can actually draw our graph. So using all the properties we have learned, this now evaluates to this kind of graph. It's not kind of like an inverse bell curve, is it? Well, it is not. Well, the true bell curve is called the Gaussian bell curve, which is e to the minus x squared. And you can also show, using some calculus, that the area under this curve, the whole area bounded by this and the x-axis, equals to, wait for it, yep, it's the square root of pi. Who never knew that e, x squared, and square roots and pi are totally related to each other? So there you have it. Finding a simple logarithmic graph with a quadratic inside, finding minimum analysis and doing such stuffs, including finding the discriminant. Anyway, I won't tell you the options, but we can tell for sure that this is the graph. See you, bye!